Good morning, everyone. We are the representative from Yuhua College. My name is Wago, and these are my partners, Dorino and Gordon. Our research project is about bone and plant fiber reinforced bioplastic. Humans have been so reliant on plastic nowadays that some people call this period of time the age of plastics. This high demand for plastics uses tremendous amount of resources. As you can see, manufacturing plastic alone accounts for 8% of the global oil production. However, more than the use of plastics, the plastic waste management has been a growing concern. And one of the alternatives to this plastic problem is bioplastics, that is made from biomass, which are biodegradable. That is, it can decompose without emitting toxic materials. However, it still has some downsides in comparison to conventional fossil-based plastics. Due to bioplastic's hydrophilic nature, it tends to interact with water, causing it to have a high water permeability. Now, this property is deadly to bioplastics, as it lowers its mechanical strength. And given water permeability and mechanical strength are interconnected, this research aims to focus on these two weaknesses. And we will try to investigate the effects of adding bones and plant fiber into the bioplastic and see if it can provide a possible solution to the weaknesses of bioplastics.
The control sample is prepared with tapioca starch, water, vinegar, and glycerol. The mixture is stirred and microwaved with maximum power for approximately 100 seconds. The heated mixture is then emptied to a metal cast covered with a layer of plastic cling wrap. The cast is then placed in an oven set at 50 degrees until it is completely dry. Bioplastic with bone powder is prepared in the same manner, but the bone powder will be added to the heated mixture and stirred well before pouring the content into the cast. The bioplastic with plant fiber is prepared with the following procedures. An amount of plant fiber is randomly laid at the bottom of the cast before we empty all the content from the microwave. Provided that the thickness of each sample was uneven, the sample was marked with 5 different sections and the thickness of each section is measured using a 0.01 mm micrometer. Tensile strength was measured using the force gauge. The extension of the sample is measured using a ruler at regular intervals. Once the sample breaks, the point of breakage are noted to find out the thickness of the bioplastic at the breaking point. For water absorption test, samples are cut into 7.5 times 5.5 centimeters in size. The initial mass was measured using an electronic balance. The samples were then left hanging in a basin containing 100 milliliters of water, with the container sealed using a plastic cling wrap, as shown in the picture. After 20 hours, the final mass was measured. The water absorbance was determined by calculating the change in mass when the sample is exposed to humid environment.
The result shows that bioplastic containing fiber only have the highest stress and the lowest strain, while the data of the control is vice versa. The bioplastic containing both fiber and bones got a balance between stress and strength. Bioplastics with various characteristics are useful for different situations. For example, the use of hard and soft plastics is different. This means that a variety of combination of plastics is needed. The table shows that adding bones or fiber can reduce the amount of water being absorbed, while the effect of fiber is slightly stronger than that of bones. But it was a totally different story when adding both fiber and bones. We expected 0.5 fibers plus 0.5 bones can absorb less water, but the truth is opposite. In conclusion, finding the weakness and strengths of bioplastics is important since the use of bioplastics will be more permanent in the future. This study shows that fiber and bones can increase the tensile strength and water permeability of the bioplastics. Although the result shows that fiber may be a better reinforcement, immediate priority should not be given compared to the bones, since bones would not require the killing or destroy plants. Further research is also needed to determine the least amount of bones needed for water permeability, as well as a better statistical analysis and proof of this study. Thank you for your attention.